Hello everyone. This is webinar 10 on vectors. Unfortunately, webinar 9 was cancelled. There was no webinar 9 because my internet cut off a few hours before the webinar and I couldn't reschedule. So hopefully you watched the recordings from last year and you found that useful. So today we're going to talk about vectors. And I've done this webinar several times, so I won't be going through the basics. So assuming you've read what a vector is, or you know a vague idea of what a vector is. If not, you can always go back to the previous webinars from last year and the previous years, just to get familiar with the basics on vectors. So a vector has magnitude, which is the length of the vector. All right, so magnitude is the length, and it has a direction, of course. Direction can be shown as an angle, yes, to some reference points of usually to the x-axis, angle to the x-axis, or angle to the y-axis. So yes, so a vector has magnitude and direction. Two vectors are equal if they have the same magnitude and the same direction. So equal vectors have equal magnitude and directions. Equal vectors have same magnitude, and direction. Okay. A vector can be represented as a column, and I will show you a few examples here. Okay, so a drone. A drone flies 12 meters due east. So this is the start. So let's say from the origin, it flies 12 meters east, and then turns 45 degrees anti-clockwise. So this is the initial direction. And so it flies 8 meters in this direction. Okay. Find the displacement vector as a column vector and determine its magnitude and direction. So basically, the displacement is a vector connecting start and finish. Okay, so we need to find this vector. And this is the displacement. Displacement is the difference between the final and the original position. Okay, so there are different ways we can do this. The easiest way would probably be to use trigonometry or the cosine rule. And if you know this angle is 135 degrees. And if this is x, so x squared is 12 squared plus 8 squared. So cosine rule, minus 2 multiplied by 12 times 8 times cosine 135. And x squared is 144 plus 64 minus, and no, we're going to do maths today, not physics. So physics will be next session. So that is webinars. Oh, let me double check. Yes, so Suvat equations have been cancelled, so we're going to do vectors today. Next is Newton's law. So unfortunately, there won't be no webinar on Suvat equations, so you can watch the previous years. Okay. Minus 24 times 8, well, 16 times 12. Okay, that's too much mental arithmetic for today. 2 times 12 times 8, 192 times cos 135, and x squared is going to be 144 plus 64 minus 192 times cosine 135, and that is well, 399. 99.2, which is a pretty much 400. So x is going to be approximately 20, I believe. Square root of answer. Yeah, 19.98, which is approximately 20 meters. So the displacement is 20 meters. Now, we need to find the direction as well. So you could use the sine rule for the direction. So theta. And you can use the sine rule. And for the sine rule, you have 8 divided by sine theta is equal to x divided by sine 135. And we already know x, so sine theta is 8 multiplied by sine 135 divided by 20, which is approximately, now I need to put that in degrees. So 8 multiplied by sine 135 divided by 20, square root of 2 over 5, square root of 2 over 5, which that's exactly that. Well, 20 is approximate. Okay, so I can't do that. So I have to do the approximate. I can't give an exact answer here. So it's 0.2828. And hence theta is arc sine. So arc sine of 0.2828, which is approximately 16.4 degrees, which looks very reasonable. So the solution, the displacement of the vector is like this, and it's the angle is 16.4 degrees, and this is why would it be minus? Yeah, it wouldn't be minus. And x is 20 meters. Yeah. Now, you would ask me, and you would be correct in saying, but we haven't really used any vectors, okay? So let's do the same thing, but now using vectors. Using vectors. Because honestly, we've just used the cosine rule and sine rule. Now, we know that vectors, if you have vector C and vector A and vector B, and then vector C is equal to A plus vector B. And this is called the triangle rule. Triangle rule for vectors. If you draw a triangle like this, the sum of the A plus B is the sum. Okay. Now, we want to write down vectors A and B as columns. So the first vector, this vector, is 12 to the right and 0 up. So the column vector corresponding to this vector is 12, 0. So 12 to the right, 0 up. The next vector, well, we want to know, we know that it's 8 meters at an angle 45 degrees. So if we draw this is 8, and this is 45 degrees, then if you multiply, this side is 8 sine 45, which is 4 root 2. And this is 8 cos 45, which is incidentally also 4 root 2. So this vector is 4 root 2 to the right and 4 root 2 up. So this column vector can be written like this. So the resulting vector, this one, is going to be 12 plus 4 root 2 and 0 plus 4 root 2, so 4 root 2. So the displacement vector and is S, displacement vector, is 12 plus 4 root 2 and 4 root 2. The modulus of the vector, the magnitude of a vector is modulus S, is the square root of 12 plus 4 root 2 squared plus 4 root 2 squared. And if you open the brackets, so this is 12, so it's 144 plus, so 12 times 4 is 48 times 2, 96 root 2 plus 8 times 2, 16 plus 16 times 2, 32. And this is so 144 plus 16, 160, 192 plus 96 root 2, which I'm pretty sure 192 plus 96 root 2 is a, okay, something went wrong. 1 32. Yeah, it is 32. Yes, thank you. It's still something wrong. I'm expecting 20. Oh, I made a mistake. 12. Yeah. It's the chat. Okay. Root 8 is 2 root 2. Yes. How is that relevant? 8. It's 8 times 2 over 2. 8. 4 root 2. Yes. I'm not mistaken here. 12 plus 4 root 2. 12. So 144 plus. Okay, 12. 12 times 4 times 2. 96 root 2. Plus 32 plus 32, 64. 144 plus 64, 28 plus 96 root 2. Sorry, I've made a mistake somewhere. I might have made a mistake here. Let's double check. 12 squared plus 8 squared minus 2 times 12 times 8 times cos 135. Of course, yeah, I made a mistake here. My calculator was in radians, and that's the reason why. So this is 343.76. So square root of that is 18.5. 18.5. So that's 18.5. And the angle's wrong. So that would be 18.5. 18.5. So that's the angle. So 8 multiplied by sine 135 divided by answer 0.3051. And the inverse sine of that is 17.8 degrees. Okay, so that's 17.8 degrees, and this is 18.5 meters. Okay, and this is also 18.5 meters. So the magnitude is the length of the vector. And the angle, if you have a vector with coordinates 4 root 2 plus 12 and 4 root 2, then the angle is actually the tangent, so theta. So theta is arctan of y divided by x. So 4 root 2 divided by 4 root 2 plus 12. And if you calculate the arctan of that fraction, 4 root 2, 4 root 2 plus 12, close bracket, it's 17.7, 17.8 degrees. Ta-da! It's the same result, obviously. So yes, we do the same problem using trigonometry and using vectors, and obviously you could see that the results are the same, right? Hope that makes sense. Now, the next problem is a very physicsy problem. So somebody asked, are we doing physics today? Well, yes, sort of. We're doing a little bit of physics, as usual. Because, I mean, we are the physics department. We are in the physics department, part of the physics department of Oxford. So obviously, everything is related to physics. At a certain location, the vertical component of Earth's magnetic field is 85% of the total. Find the horizontal component. Well, that seems very obvious, right? Like, if you have a magnetic field, so what does that mean? Well, magnetic field, magnetic field of Earth inclination. Hopefully, we can get some ideas. Not sure what this picture is referring to, but we'll just use that. And so if this is the planet Earth and you're standing here, you can see that the magnetic field is actually pointing somewhat that way. So magnetic field. Magnetic field. So if you're standing, where are you standing? On a street. If you are walking along the street, the magnetic field might as well be passing like this. Magnetic field. Magnetic field. Field. So if you take a compass and you put it in your hand, obviously compasses are designed to work horizontally, right? When you take a compass, you're not really interested whether it's goes down or up. We're only interested in the direction. So if you take a compass needle, it will point in that direction. But the compass needle only takes into account the horizontal component, if that makes sense. There are 3D compasses that will show you the vertical component as well. And that kind of compass will actually point down and left rather than just left. Compass 3D compass, 3D compass. I don't know if that makes sense. Definitely doesn't. Inclination. Um, yeah, this is a vertical compass, which shows you not only the horizontal component. Well, this one can actually only shows you the vertical component. So if you suspend a compass needle like that, it will bend like this. So it's quite interesting to see. If you ever encounter a compass like this, do have a look. It's fascinating. Okay, so you have a magnetic field, and it says that the vertical component is 85% of the total. So this is the total field. This is the total field to be total. And it says it has two components, the vertical component and the horizontal component. And they say that this is B vertical and this is B horizontal. They say that B vertical is 85% of B total. So B horizontal is how many percent of total? And I think a lot of you can see that it is a trick question, right? Because the answer is not 15. Okay? Not 15%. To answer this question, we need to use vectors. So the B total. So basically what this says is that the vertical is 0.85 of B total. So if you want this angle, theta, you can use trigonometry. You have cosine cos theta is adjacent over hypotenuse. So it's B vertical divided by B total. But we know that the vertical is 0.85 B vertical. B is magnetic. B stands for magnetic field. We use B for different reasons. And B total. B total. So B total cancels out and we get 0.85. So we can work out the angle, theta. And theta is 0, cos of 0.85 is 31.79 degrees. That's the magnetic inclination. And we can find the sine theta. Sine theta is sine 31.79 degrees, which is sine is 0.5268. And B horizontal, well, B horizontal is actually B total multiplied by sine theta. If you look at this triangle, you will realize that it's the horizontal component. And this is 0.5268 of B total. So the horizontal component is actually 53%. 53% of total. Interesting. So you have a magnetic field. You have a magnetic field which goes like this. B total. total. The vertical field is 85% of B total. And the horizontal is, yeah, it's the same. Sorry, is 52%. 53% of B total, which is bizarre. Yes, exactly. It's pretty much Pythagoras. You could say does make sense. If this is 100%, so that's 1, and this is 0.85, then you can do square root of 1 minus 0.85 squared, which is 0.53. It is you can use any method you like, as long as you understand. You understand and can explain it. So yeah, quite fascinating. So with vectors, horizontal and vertical don't add up to 100%, if that makes sense. But they do if you square them. Okay. Next, a ring rests space. The ring rests on a smooth horizontal surface and is pulled by 3 strings so that it remains in equilibrium. Okay, so we have a ring. A string A pulls east. String A pulls east. String B pulls 60 degrees north of west. So 60 degrees north of west, that means this way. So 60 degrees, that's B. And C pulls directly south. Express the force in string C in terms of the force in string A, and find the relationship between forces in string A and B. Okay. To answer this question, you need to resolve vector B. Resolve vector B into horizontal and vertical components. So you have B vertical and B horizontal. We call it BX and BY. BX and BY. These are the components. And using trigonometry, we can say that BX, the horizontal component, is B multiplied by cos 60 degrees, which is 1/2 B. And BY is B multiplied by sine 60 degrees, which is square root of 3/2B. Now, because this string is in equilibrium, or ring is in equilibrium, that means that this force must equal to this force. So By must equal to C. Or in other words, square root of 3/2B must equal to C. Also, and Bx must equal to A. Bx must equal to A. Or in other words, 1/2 B must equal to A. And therefore, we can, what does it say? Express the force in string C in terms of the force in string A. So we can divide. So this equation 1 and 2. Divide equation 1 divided by equation 2. And you can do square root of 3 over 2b over 1/2 b. So I'm dividing this by that, and it's equal to c over a. B cancels, 2 cancels, and we got c is equal to square root of 3a. So the force in C is square root of 3 times bigger than in A. And A and B, well, we know that A is force in string in A and B. Yes, so the force in A is a half of the force in B. Okay. So A is a half force of B. So example, if we know that A is 10 newtons, for example, B would be 20 newtons, and C would be square root of 3 times A. So 10 square root of 3, which is approximately 17.3 newtons. Let's see if that makes sense. So this is the ring. A pulls to the right, so that's 10 newtons. B pulls down, which is 20 newtons. And C, no, what am I saying? No, C is down. A is to the right. Yes, A to the right. This is 17 newtons. And this is 20. This is 20 newtons. This is 17 newtons. Yeah, and it does kind of make sense. So this is A, this is B, and this is C. Okay. So hopefully that makes sense. Next, two vectors A and B form adjacent sides of a parallelogram. Find the angle between the diagonals of this parallelogram. So you have a parallelogram. A and B. A and B are vectors forming the sides of the parallelogram. So this is 4 minus 7, and B is minus 2, 5. Find the angle between the diagonals. Well, to find, first we need to find the diagonals. And using the parallelogram rule, this vector is actually A plus B. And this vector is B minus A. And we need to find the angle between the diagonals. Well, let's find the A plus B first. The vector A plus B is going to be 2 minus 2. 2 minus 2. And B minus A, vector B minus A is this minus that, so minus 6, 12. Right. To find the angle between two vectors, so cos theta, cos of the angle between two vectors. So we have vector A and vector B. And if you want to find the angle between them, it doesn't matter. A minus B or B minus A, it doesn't matter which one you take. A minus B would be the other way. If you take the vector this way, it would be A minus B. We were looking for the angle, so we're going to find this angle or this angle. So we can find both. Right, so angle between two vectors is equal to the product of the two, scalar product of the two vectors divided by the modulus of A times the modulus of B. So the length. So it's the scalar product divided by the product of the length of the vectors. And if, just remind you, scalar product, scalar product, or the dot product. If A, vector A is A1, A2, and vector B is B1, B2, then the scalar product is A times B, and that's equal to A1, B1 plus A2, B2. The modulus, the length of the vector, is Pythagoras theorem, so A1 squared plus B1 squared. And of course, sorry, A1 squared plus A2 squared. What am I saying? And B is obviously square root of B1 squared plus B2 squared. Right, so we want to find the cosine between the diagonals. Theta is A times B, so this times that. So 2 times -6 plus -2 times 12. Okay, divided by the modulus of A. Modulus of A is square root of 2 squared plus 2 squared. The square root of, and the modulus of B is 6 squared minus 6 squared plus 12 squared, which is -18, -24, -18, -24, -42, divided by root 8, multiplied by 36 plus 44, 6 root 5. Okay, that makes sense. Which is approximately 42 divided by root 8 multiplied by 6 root 5 negative. That doesn't make any sense. -12 -24 -36. That's bizarre. Where did they get -36 over root 8 times 6 root 5 minus 3 root 10 over 10. Well, that's exactly equal to minus 3 root 10 over 10. And theta is approximately, is arc cos minus 3 root 10 over 10, which is 161. 61.6 degrees, approximately 161.6 degrees. So we have found the wrong angle. We actually found this. Well, we found this angle, which is 161 degrees. So this angle would be 180 minus that, which is 18.4. 18.4 degrees here. They don't specify which angle we need, so either answer will be correct. All right, so we can, that's problem 4. Problem 5, I really wanted to do a problem very similar to problem, I think 8, was it? Let me double check. Problem from the assignment. really wanted a very similar problem to problem 9. Similar to problem 9, but I sort of messed up because this problem doesn't have a solution. I will show you why it doesn't have a solution, but hopefully you'll understand the method that I'm using. Okay. Similar to problem 9. 9 is with a star, but has no solution. Okay. So we have a vector. So if two vectors are perpendicular, if vector A is perpendicular to vector B, so this is 90 degrees, A and B, then if A is perpendicular to B, then the dot product is modulus A modulus B cosine 90 degrees. But cosine 90 degrees is 0. So the dot product is 0. So if vectors are perpendicular, then the dot product is 0. And it's an important rule that you can use in the future. Therefore, if vector 2v plus 2w, v plus 2w is perpendicular, this is a vector, to 5v minus w, then that means v plus 2w multiplied by 5v minus w is equal to 0. Now, here I will be omitting the lines. You should do that. Not the lines, the arrows. Further omitting the arrows. But you can use this rules of multiplication works with vectors. So here we're going to be v times 5v. So v that's going to be 5v squared, 5v squared minus vw. So what is v squared? Well, v squared is the multiplication of a vector onto itself. V squared is equal to the modulus of v squared. It's an important property of a vector because it's literally multiplying the vector by itself. So vector v multiplied by vector v is the modulus of vector v multiplied by the modulus of vector v times the cosine of the angle. But cosine between vector v and v is 0 because it's the same vector. So the angle is cos 0 degrees. Then therefore v times v is equal to v squared because this is just 1. Okay. 5v squared minus vw plus 10wv minus 2w squared equals 0. All right. In other words, 5v squared plus 9vw minus 2w squared must be equal to 0. That's the first equation. The second equation is that the two vectors, so 3v minus w multiplied by v plus 4w is equal to 0. And if you multiply those out, you get 3v squared plus 12vw minus wv minus 4w squared equals 0. 3v squared plus 11vw minus 4w squared equals 0. And that's the second equation. Right. Remember that v and w are vectors. They're not just numbers. However, moving on, we can multiply this by 3, multiply this by 5 to eliminate v, and then 15v squared plus 27vw minus 6w squared equals 0. Here we have 15v squared plus 55vw minus 20w squared equals 0. Now subtracting 2 minus 1, so this minus that, and we get 28vw minus 14w squared equals 0. And here we can say 2vw is w squared. So that's very useful. Let's write it down properly. W modulus of w squared is equal to 2 times vw. This is how it should be written down properly. Now, if you substitute that into this equation, that's where you get into trouble, where I got into trouble when preparing this webinar. Plus 55 VW minus 20. Oh, let's not use this one. Why would we? We put that into here, and then we get 3v squared plus 11vw minus 8vw equals 0. 3v squared plus 3vw is equal to 0. And 3vw is equal to minus v squared, which is a contradiction because this is impossible. Because minus v squared is literally minus modulus v squared. So that's a number, and it's a positive number. And VW, we already know it's a half of W, modulus W squared. So VW here is a positive number, and here VW is negative, so it's a contradiction. So there, as I said, this problem has no solution, but what would you do next if that was a reasonable number? If it wasn't like that, let's say if it was just v squared, then you could just put that into the equation. So cosine of the angle between v and w. No, it's not the case. For problem 9 has a solution. I just modified the problem 9s so that I'm not doing the same problem, but then I realized I've modified the problem so much that it doesn't have a solution. So the angle between them is v times w divided by modulus v modulus w, and then from here you could see that square w squared, so w modulus w is equal to square root of 2 square root of v times w, and from here v modulus v is square root of negative VW. It's obviously impossible. You can't have a root of negative number. And then you just put that into here. You got V times W divided by square root 2 square root of V times W times square root of negative 1 square root of V times W. VW cancels out, and you get cosine between the angle between V and W is equal to some number, and that angle is some angle. Yeah, so here we have a root of -1, so we are in trouble here, but it doesn't have real solutions. Anyways, I hope that makes sense. This is the method you can use to solve problem 9. But with problem 9, you do get a reasonable number. So I'll just make a note of that. In problem 9, in problem 9, 9 with a star, this is a number that makes sense. Right, so moving on. We got number 6. And this is super easy. I'm gonna I'm not but I'm gonna do it in a difficult way. Let's put it that way. The sides of a triangle. So you have a triangle, ABC. Let's, for convenience, put this triangle A, B, and C. We know that AB is 9. This is 9. AC is 12. BAC. AC is 12, and CB is BC is 14. 14. Now, this can be solved using the cosine rule. However, I'm sort of going to use vectors. Okay. Now, let's say that A has coordinates 0, 0 for simplicity. So we put A at the origin, and B has coordinates 9, 0. And C has coordinates C has coordinates x and y. X and y. So we don't know x and we don't know y. So, but what do we know? Well, we know that AC is 12. So the vector AC has is a vector x, y. So it's x to the right and y up. And we know that the modulus of AC is 12. That means that square root of x squared plus y squared is 12. On the other hand, we know that CB, vector CB, is 9 minus x, and 0 minus y. 0 minus y. And that is 9 minus x minus y. And we know that the modulus of CB is 14. And that means that 9 minus x squared plus minus y squared, square root, must equal to 14. And we can use this first equation and second equation to solve for x and y. Solve 1 and 2 simultaneously. For x and y. All right, so we square both sides, of course. For the first equation, we square both sides, and for the second, same. So x squared plus y squared equals 144. And the second equation is 9 minus x squared plus y squared. We can ignore the minus because it's 196. So from here, we get x squared plus y squared is 14. 81 squared minus 18x plus x squared plus y squared is 196, and we can subtract. So we can do this minus that, and subtract. So we get 81 squared minus 18x equals 196 minus 144. So 18x is equal to 81 squared plus what? Not 81 squared, of course. What am I doing? I just imagined doing 81 squared. Yeah. Did somebody say 80? It's not 81 squared. I didn't see what you've written on the chat, but I already knew something's wrong. Of course, it's not 81. So thank you for that. 18 is 81 plus 144 minus 196. And let's see if that gets us anywhere. So 81 plus 144 minus 196 is 29. So x is 29/18th. And we can find y, I guess. Well, do we need to? What was the question? Oh, find the angle. Oh, we don't need to. Oh, no, we do. Sorry. We do need to find y. Well, let's use the easiest way to find y. Y is 144, or plus minus 144 minus x squared. And that means 29/18. Square root of 144 minus answer squared. Okay. It's approximately 11.89. Therefore, we found vector AC. We found vector AC, and that's equal to 29/18ths and 11.89. And we have vector AB. AB is equal to 9, because it's 9 to the right, 0 up. So we have two vectors, AC, and AB. And to find the angle between the two vectors, so angle BAC, we need to multiply AC times AB, the dot product of the two vectors, divided by the modulus of AC multiplied by the modulus of AB. So multiplying the two vectors, it's 9 times 8 is 29/2 plus 0. Oh, lovely. And divided by the product of these. So that's 12 multiplied by AB, 9. Okay, so that's 29 divided by 12 times 18 times 18, 216. So that's cosine of the angle BAC. So angle BAC is arc cos of 29/216. And that is 29/1 arc cos of, so is 82.3 degrees. Okay. There are obviously much easier ways of doing this problem. I really wanted to do it using vectors. So hopefully that solution makes sense to you. Right, so How do you find the vector between the x-axis and a vector? You mean the angle between axis and a vector? Well, you take any vector on the x-axis. Like, look, let's say you have a vector. You have a vector, I don't know, 3, 4, right? And you have the x-axis. Well, take any vector on the x-axis. So a vector on the x-axis would be like 3, 0, for example. And then to find the angle here, so cosine theta would be multiplication, so 3, 4, multiplied by 3, 0, divided by the length. So the length of this vector is 5, so square root of 3 squared plus 4 squared, multiplied by square root of 3 squared plus 0 squared. So that's 9 over, that's 5 plus 3 times 3, so 15. So theta is arc cos of 9/15. Arc cos of 9/15 would be 53 degrees. 3 degrees. Does that answer your question? Take any vector. Take any vector on the x-axis. Okay. Great. Next. Problem 7. In triangle ABC, the side lengths are 7, 11, and 10. So A, B, and C. So 7, 11, 10. Point M lies on BC such that M, such as BM to MC is 2 to 3. Find the length of AM. AM. Okay. Um, hmm. Well, we could place the triangle in a coordinate system again. Just wondering. AB 7, AC 11. Yeah, we can kind of use the same method. So place A at point 0, 0, point C at 11, 0, and point B at unknown, which is X and Y. Well, you know what? Let's call it B, B1, B2. So these are the coordinates of B. Okay. We know that this is 7, this is 10, and this is 11. And well, yeah, let's find B. So we know that AB, modulus of AB is B1, B2, and modulus of AB is 7. Therefore, B1 squared plus B2 squared is 49. Now, BC is 11 minus B1 and 0 minus B2. So it's the end minus the beginning. And BC, the modulus of vector BC is 10. therefore 11 minus b1 squared plus b2 squared equals 100. You can subtract bottom minus 10. So it's 121 minus 22b1 equals 51. So b1 is equal to 121 minus 51, 70. So b1 is 70 over 22. Over 22, 35 over 11. 35 over 11, which kind of makes sense. And b2 is the square root of 49 minus b1 squared. So square root of 49 minus 6 square root of 154 over 11. Okay. I don't know if we should keep it exact, or we can try keeping it exact for now. All right, so now that means that vector AB is 35 11th and 6 root 154 over 11. What do we know about M? Oh, we don't know M, but we know that BM is 2/5, because this is BM to MC is 2 to 3, so BM is 2/5 of BC. And therefore, we can say it's 2/5 of BC, and BC is 11 minus B. So it's 11 minus 35 over 11. 86 over 11. And BC, so minus B2. Minus 6 root 154 over 11. 86 times 2. 6 times 2. 172. 172 over 55. And here we have 12 to 154 minus over 55. That's BM. And we need the length of BM. Oh, no, we need AM now. AM is AB plus BM. AM is AB plus BM, which is 35 over 11, 6 root 154 over 11, plus 172 over 11 over 55, plus minus 12 over 154 root over 55. I get a feeling that this is not going to be pretty. Plus 172 over 55. So it's 347 over 55. And this one is going to be 6 over 11 minus 12 over 55. 11 154 over 55. All right, and now we need to find the length of AM. Is the modulus. The length of AM is just the length of that vector. So it's the square root of 347 over 55 squared plus 11 154 over 55 squared. We get something. So 347 squared plus 11 squared squared times 154. Uh, 6.78 approximately. Hopefully that makes sense. So, okay. Now, the next problem. The next problem is one of my favorites. This is similar to the last problem on the assignment. A uniform heavy cable of mass m. So you have a heavy cable. A and B. And it's making an angle of 40 degrees. So here it's making an angle of 40 degrees. And here it's making an angle of 50 degrees. The mass of the rope is m. And we need to find the tensions in the cable at A and B in terms of M and G. So we have a tension at A, and we have a tension at B, So they're pulling the rope. Now, and there's the mass. So somewhere here, there's the mass of the rope pulling down, which is mg. Mg is the gravitational force on the rope. And because these forces are in equilibrium, because the rope is stationary, that means the forces are in equilibrium. Rope stationary. That means forces in equilibrium. So we can write down TA, TB, and mg. They must balance each other out. We're going to split TA into components. So TAY and TAX. That's the horizontal and vertical component. And for this part also. So TBX and TBY. And now we can write down two expressions. So we can write TAY plus TBY must equal to mg. And on the other hand, TAX must equal to TBX. So the horizontal forces must equal to each other. Right? So the forces pulling up, 18 squared. It was 18 over, yes, 18 squared, 347 squared plus 18 squared times divided by 5 squared, 7.5. 7.50. Okay. Right. But now we know that this angle is 50 degrees. And we know that this angle is 40 degrees. So this is going to be, so TAX is actually TAY cos 40. TAY is TA sine 40. TBX is TB cos 50. And TBY is TB sine 50. And now all you need to do is just plug them in, because literally TAY is TA sine 40 plus TB sine 50 equals to mg, and TAX, which is TA cos 40 must equal to TB cos 50. So how would you solve that? Well, you would say that TA is cos 50 over cos 40 TB, which is approximately, well, no approximates for now, TA, and then you just solve that. So T cos 50 cos 40 TB plus TB sine, times sine 40 plus TB sine 50 equals to mg. So TB, open bracket, tan 40 multiplied by cos 50 plus sine 50 equals to mg. So TB is equal to mg divided by tan t cos 50 plus sine 50. So I'm not substituting any values, but you always can always substitute values, because tan 40 cos 50 are all known values. You can find them on a calculator. And TA, because it's cos 50 divided by cos 40 multiplied by TB, cos 50 divided by cos 40 multiplied by mg over tan 40 cos 50 plus sine 50. So you can get a similar expression. You can get mg cos 50 cancels. This becomes tan. So tan 40 cos 40. Oh, so there's sine 40. Sine 40 plus tan 50 cos 40. Okay. So you can get a similar expression. So yeah, that answers the first problem. The first so find TA and TB. Now this for problem B is quite a sophisticated problem. It says find the masses. You have the mass on the left and mass on the right. What to do this, you need to consider the two pieces of rope separately. So you have a piece of rope on the left, a piece of rope on the right. And here you have two forces, so TAX and TAY. And here you have the mass of the on the bottom. There's the other rope, TC, pulling to the right. So the right rope is pulling the left rope. And there's the mass of the left-hand side, so the mass of the left G. And then here you have mass on the right G. There's also TC pulling this way, and TAY and TBY and TBX. And looking at these two pieces, you immediately understand that TAY must equal to MLG, and TBY must equal to MRG. And if you want the ratio mass on the left g divided by mass on the right g is simply TB TAY divided by TBY, which you already know because that's TA multiplied by sine 40, and this is TB multiplied by sine 50. And just substituting the values from the previous one, you find the ratio. So ratio ml over mr. Amazing. Okay, I hope that was useful. I I tended to do very similar problems to the ones in the assignment. Hope that helps, and I'll see you all. See you all on the 19th, on the 26th, so next week. Okay, enjoy.